You know, we talk a lot about cybersecurity, but have you ever really stopped to think about what keeps your lights on or the water flowing from your tap? It turns out there are two totally different worlds of security out there, and one of them is this constant, unseen battle to protect our actual physical reality. So yeah, let's get into it.
So you've got these two worlds, right? On one hand, there's information technology, or IT. Just think of a bank. Their entire universe revolves around one thing: protecting your data, your account info, your password, all of it. But then you have this other universe, operational technology, or OT. This is the stuff that runs power plants, factories, you name it. And for them, it's not about the data. It's about the physical process. The absolute number one goal: keep things running. Period.
Okay, so in the security biz, there's this fundamental concept called the CIA triad. And no, not the spy agency. It stands for confidentiality, integrity, and availability. Think of them as the three legs of a stool that hold up all of security. But here's the twist. Depending on whether you're in the IT world or the OT world, the importance of each of those legs changes dramatically.
All right, check this out. In the IT world, everything is about confidentiality. I mean, look at that bar. It's huge. If a bank's data gets out, it's an absolute catastrophe. Game over. Integrity, making sure the numbers are right, that's a solid second. But availability? If the banking app is down for a few minutes, super annoying for sure, but the world doesn't stop spinning.
Now watch this. We jump over to the OT world, and it's like we're in a parallel universe. The whole thing is flipped on its head. Here, availability is the undisputed king. A power grid cannot go down. An assembly line must keep moving. Integrity is still really important, of course. The process has to be correct. But confidentiality? Look how tiny that bar is. Honestly, who cares if someone knows the temperature of a boiler, as long as that boiler keeps working and the power stays on? And that right there brings us to the heart of this whole thing, this relentless, all-consuming quest for uptime. We're going to really dig into why keeping that system running 100% of the time isn't just a goal, it's pretty much an obsession in the OT world. And let me be clear, the stakes are just massive. This is not an exaggeration. When an OT system fails, like a water treatment plant or the electrical grid, we're not talking about your Netflix buffering. We're talking about the water from your tap stopping. The lights going out, the very fabric of our modern world starts to come apart. So if uptime is the holy grail, what's trying to stop it? Who are the bad guys in this story? And yeah, you're probably thinking about hackers and cyber attacks, and you are not wrong. But, and this is a really big but, some of the most dangerous enemies are already inside the gates. Yeah, this number right here, 100%. This is one of the biggest internal threats. You see, the brain of these systems is an industrial controller. And if its processor gets completely maxed out, hits 100%, it basically has a meltdown. It can't think, it gets behind, and to prevent something truly dangerous from happening, the whole system just shuts itself down. It trips, just like a circuit breaker in your house. So how do you stop that from ever happening? Well, smart engineers build in massive safety buffers. It's kind of like having a 10-lane highway, but only ever letting cars use 5 of the lanes. So a controller might be able to handle, say, 2,000 signals at once, but they'll design the system so it never, ever has to deal with more than 1,000. That leaves this huge cushion, a giant safety net, to make sure it never even gets close to that breaking point. Okay, so we've got the internal threats covered. But, of course, there are the external ones. And here's the key thing about attackers in the OT space. A lot of the time, they don't want to steal secrets. They want to create chaos. They want to knock things offline. Their main target isn't confidentiality, it's that number one priority we keep talking about: availability. To get how they do this, you have to understand how computers connect online. It's called a three-way handshake, and it's basically like a super polite phone call. The first computer sends a message saying, "Hey, can we talk?" That's the SYN. The second one answers, "Sure, I'm listening." That's the SYNAC. Then the first one confirms, "Awesome, here I come." That's the ACK. And bam, they're connected. Pretty simple. Well, here's where it gets nasty. An attacker can weaponize that politeness. In something called a SYN flood attack, they just hammer a system with thousands, maybe millions, of that first, "Hey, can we talk?" request, but they never follow through with the rest of the conversation. Imagine a call center getting a million phone calls at once, and every single time the operator picks up, the line just goes silent. The system gets stuck holding all these ghost connections, and pretty soon all the phone lines are jammed. No legitimate calls can get through. Availability, totally destroyed. Okay, so we've seen the threats, both internal and external. It can sound a little scary, right? But now for the good part. How do we fight back? What's in the playbook for guarding these critical processes and defending availability at all costs? So, what's the big answer? How do we win this quest? How do you actually build a system that can take all this pressure from inside and out and just stay online 24/7? It really boils down to three core layers of defense. First up, redundancy, redundancy, redundancy. For every critical brain, there is an identical twin, a hot backup, ready to take over in a millisecond. Second, you build resilient networks with multiple pathways, so if one road is blocked, data can just take another route. And third, you test the living daylights out of it in something called a factory acceptance test, or FAT. It's basically a full-on dress rehearsal and stress test before the system ever goes live. And even inside that fortress, there's a clear pecking order, a hierarchy of what gets protected first. At the very top, the absolute highest priority are the controllers, the brains of the operation. If they fail, it's all over. Next up are the network switches. Think of them as the nervous system connecting everything. And finally, you have the HMIs, the screens and keyboards operators use. They're like the eyes and hands. They're important, sure, but if one screen goes dark, you can usually move to another one. The brain and the nervous system, they have to be protected above all else. And this really hammers home the core philosophy. In the OT world, having a backup plan isn't just a nice to have. It's not a luxury. In fact, a lack of redundancy is officially considered a major security flaw by standards bodies like NIST. It's not an option. It is the bedrock of how you keep these systems secure and online. Okay, let's just zoom out for a second here. We've been talking about controllers and network attacks, but why does any of this really matter to you and me in our daily lives? Well, this unseen battle for uptime, it affects literally everything. Because keeping our physical world running isn't just one thing. It's this incredible symphony of different disciplines all working together perfectly. You need the precision of the engineers building in those safety margins. You need rock-solid, reliable hardware. You need resilient networks. And you need the vigilance of cybersecurity defenders standing guard. All of these pieces have to be in perfect harmony to win that quest for uptime. So the next time you flip on a light switch or turn on the faucet, just take a second. Remember that behind that simple action, there are invisible systems fighting a constant, high-stakes battle to stay online just for you. And that leaves us with one really important question to think about. Are we doing enough